So what we have here is a group velocity and a phase velocity concept that we have learned in the last class. And as I said, if you remember the formula, derivation, we have already done it. Phase velocity is equal to omega divided by k. And when we talk about group velocity, it is d omega divided by dk. So we do understand that phase velocity and group velocity are different in the sense that a wave, when it starts traveling, a single entity of a wave is actually nothing but talking about a phase of the wave, and that phase, the velocity with which it travels, is called a phase velocity. On the other hand, if we have a group of waves, which will be actually a combination of n number of waves, okay, and if you just combine them, you are going to get a resultant value, and these velocities, or the wavelength and all, are not going to vary much. So that means they are going to form certain kind of pattern like this, and this is the group of waves that is traveling. So this group will actually travel with this velocity, whereas a single wave will travel with this velocity. So this is what we have learned in our last 2 or 3 classes. Today what we are going to do is we are going to take up this question. The question says, show that the phase velocity of matter wave is greater than speed of light. Now this is something which you might think that okay, it's violating the laws of physics. Something cannot move greater than the speed of light. But remember, when we look into it practically, this is the one that we usually observe, group of waves. Okay, so if you are having a group of waves, that means within this group there are a number of waves. These waves will travel very fast within this region inside the wave. Okay, but the group as a whole, which we realize in our day-to-day life, is moving with a lower velocity. So this is something which we are going to prove mathematically. So let's just prove it, and then maybe you'll realize that yes, it does show that the speed is greater than the speed of light. So we will start with phase velocity. The explanation here, we already have it. So the relation is phase velocity is omega Vp is equal to omega divided by k, and then we can write down Vp is equal to omega k का मतलब 2 pi divided by lambda. So we can simply write it down as omega, it's nothing but 2 pi into frequency. So maybe I can write down new frequency and into lambda divided by 2 pi. Right, so that means that I can simply write it down as new lambda, right? So that's my relation. Now if you go for de Broglie's hypothesis, which we have already seen, lambda is equal to h divided by momentum m into v. So we can replace it, therefore Vp, which is the phase velocity, is equal to nu into lambda is h divided by mv. But what is h nu? H nu, okay, again we have E is equal to mc square. So that means E is also equal to h nu, as we have already seen. We already know it, h nu. So h nu is mc square, because E is mc square, E is h nu. So h nu can be written as mc square. So divided by mv. And when we are saying that, maybe we can just, and this is c square by v, so I can write it down as c divided by v into c. So that means phase velocity, if we break up the relation, we can write it down as c divided by v into c. Okay, so this is actually a numerical problem, you can say, and the question would be, show that the phase velocity of matter wave is greater than the speed of light, and marks may be around 2 marks for this. Okay, because this is a very short derivation. Now look here, this obviously shows that the phase velocity is greater than the speed of light. How? Because since whatever velocity we are considering for a system, and we have also seen it in the special theory of relativity, v is always less than c. Okay, this implies that C by V will obviously be greater than 1. C by V is going to be greater than 1. So you take a value which is greater than 1 and multiply it with C. You're definitely going to get an answer which is going to be greater than C. Right? So that means therefore Vp, which is the speed of the phase of the wave, is greater than speed of light. So this is the proof. So you have to remember this, okay, and do the proof. So that's important here. So this will be a question which might be there, okay, and if we just write down some concluding remarks here, we can say the packet is the de Broglie wave. So if you consider the entire packet, that is actually the de Broglie wave. De Broglie wave, which moves with velocity v by a phase. So if we have a group of waves, you have individual waves within the group, which is called the phase of the wave, which will actually travel greater than the speed of light, which travels greater than c, the speed. Okay, we may or may not write this sentence, but then in order for proof, I think up to this much it's okay. Okay, so that's the proof for how the phase velocity is greater than the speed of light. Another important question that might be asked, okay, let me just give it to you in the question form. Okay, so this is also a very important question, okay, and the question is something like this. Okay, so it will be show that, okay, the group velocity, I'm giving it to you in the form of a question so that it's easier to remember and answer, of matter waves associated with a relativistic particle. Let me just write down the question and then I'll explain what exactly we are supposed to find out, is equal to the particle velocity. So this is slightly longer derivation, maybe up to 5 marks can be given. Okay, particle velocity, maybe up to 5 marks. Okay, so the question says, okay, let's just read the question, and this is totally mathematical. Okay, we're going to derive it now, and we are going to derive it using all the mathematical steps that we know. So you see, the question is, show that the group velocity of matter waves, okay, that means group velocity of matter waves kya hota hai mera, how do I represent it, Vg, is associated with a relativistic particle. That means we are talking about a mass which is relativistic mass. That means we are going to use this relation m0 divided by 1 minus v square by c square. So this is a relativistic particle, means the mass would be this. So associated with a relativistic particle is equal to the particle velocity. That means Vg is equal to Vp. Okay, particle we can say. Don't take phase. This is for our relativistic particle, very important. Okay, so we are going to look into this relation. So let's just go for the derivation. Okay, derivation. Okay, let's see how we can derive it. So we'll start with the relationship for group velocity, which we already know. Okay, so here really I don't need to explain much, it is all mathematical. I'll try to break each and every step into more details so that you can actually follow this. So let's just write down group velocity. So we know group velocity Vg is equal to d omega divided by dk, right, which we already know. And we will just slightly modify this. We can write it down as d omega divided by dv, the rate of change of angular frequency with velocity, divided by dk divided by dv. And this is my relation 1. Okay. Now what I'm going to do, we are going to find out d omega by dv separately, and then we are going to find out dk by dv separately. And when we put the values, okay, put the result and cancel out, we'll see that this will be equal to v, the velocity of the particle. Okay, so this is what we are going to do. So whenever you are doing solving these kind of problems, always remember what's the final aim. That's very important, right? So let's do for d omega by dv. तो उसके लिए तो पहले d omega जानना पड़ेगा. I should know what is d omega, right? So we already know omega is equal to 2 pi nu and so on. Okay, so we are going to use those results. So let's start. Okay, yeah, you can actually start in the way you feel convenient, but then I will give you the entire derivation first. So we know h nu is equal to mc square, because if it's the same system, the energy is same, conserved, and we can multiply 2 pi on both sides, right? So I can write down 2 pi h nu is equal to 2 pi mc square. I hope you know what we are trying to do. 2 pi nu is omega. So that means we can write down this as omega is equal to 2 pi. If you are confused anyway, just tell me. 2 pi mc square divided by h. Okay. So we have this relation. But here we know 2 pi is a constant. C square, speed of light in any medium, would be constant, and divided by h is again a constant. The only variable here is m. Okay, so the mass is not a constant. M is not constant and is relativistic. So if I write down sentences and explain, it will take a very long time. So I'm not writing down every sentence here, but when you write down in exam, we have h nu is equal to mc square. You can just write down few sentences here. E is equal to h nu is equal to mc square, equate them and so on. Okay, you can be a bit more detailed. That will be okay. Therefore, we can say omega is equal to 2 pi c square divided by h into m. But what is my m? M is m naught divided by root over of 1 minus v square by c square. So it's all mechanical because you know the formula, so you can easily put it and do your calculations. So I can write it down as 2 pi c square into m naught divided by h. Now this m is constant because this is the rest mass. Rest mass is always constant. And this is 1 divided by this, so I can just take it in the numerator. It will be 1 minus v square by c square, whole thing to the power minus half. Okay, so we have to find out d omega by dv. Do we have v here? Yes, we have. So that means we can find out d omega by dv. We can differentiate it. Okay, so let's differentiate. Now we have to find out what is d omega by dv. So d omega divided by dv is equal to, so I will take these constants out. Now I think this is all about integration, differentiation, sorry, divided by h. So that's my constant. And dv, so I'll take this entirely, nx to the power n minus 1. So what is my n? Minus half, so I'll bring it here. Nx to the power n minus 1, so this is 1 minus v square divided by c square. N minus 1 means minus half minus 1, which is minus 3 by 2. But then this is also a function of 1 minus v square by c square, so that means d dx of 1 minus v square by c square. So minus is there, so I will put a minus sign here, and then this would be v square का d dv लेंगे तो 2v रहेगा, and then you have got c square. So I hope you can tackle the differentiation, normal standard differentiation. Okay, so this is the differentiation of this. right? We just do it by substitution method and all, but usually we don't do it because we have done it so many times that we really don't need to show that step in detail. Don't need to show it here also. Okay, so you know this c square will get cancelled with this c square. Okay, we're just getting rid of c square here, so I can just simply write it down as 2 pi m naught divided by h. We have it here. And minus minus here to plus ho gaya, so I don't need to consider this, right? What else? 2 also gets cancelled here. This 2 and this 2 will also get cancelled. We are left out with 1 minus, you can do it on your own, you can do it in detail for personal satisfaction, minus of 3 pi 2 into v. We have a v here. This is very important. So whenever you do it, please don't mix up, you do it clearly. That's very important. So that is number 2. So this is d omega by dv. Okay, so mark this. This is the numerator that we have already derived. What we need? D omega by dv. We have found out d omega by dv. What now we need is dk divided by dv. So now we are going to derive for dk divided by dv. Okay, so let's derive for dk divided by dv. Okay, so you take your time and solve and check if you're getting this. Okay, so the only thing that I have not done in detail is this differentiation, and this is something which I expect you all to do. Okay, so I hope you'll be able to get it. Now dk by dv chahiye na, so we have to start with some value of k, and what we know is k is equal to 2 pi divided by lambda. Okay, today it's pure maths. Okay, not much of difference. So this is 2 pi and lambda is equal to nothing but h divided by mv. Matter particle related with de Broglie wavelength because it's matter waves, right? Implies k is equal to 2 pi divided by h into mv. Okay, so we have it here. So we can differentiate it now. The answer is no, because it's v here, but then this is relativistic mass, so that means this mass also we have to check, okay, in terms of relativistic value. Therefore we can write down k is equal to 2 pi divided by h, constant, no problem, but mass is relativistic mass, so it is m naught divided by root over 1 minus v square by c square into m, sorry, not m, just v. We have already taken m to be the relativistic mass into v. Okay, so we have this relation. Now what we are going to do is we are going to do certain adjustments to do it correctly. So we'll take it to be k is equal to 2 pi m naught, or observe these steps very carefully, otherwise might make some mistakes, into h. So these things are constant. I'll just keep it together, and everything else I will take it in the numerator. Okay, we'll see why we're doing it. It will become a bit easy. V is on the denominator, so if I take it at the numerator, it will be 1 divided by v, and at the numerator we already have this, so I will take this root over of 1 minus v square by c square, right? Now this is 1 by v. If I take it inside the root, it will be 1 by v square. Okay, so I can do it. This is for, you know, making the differentiation easy. If you don't do it, it's fine. You can use the product rule and then differentiate. You're going to land with the same answer. You can just leave it here, okay, and then you can use the product rule. You have got v and 1 divided by root over of 1 minus v square by c square. You differentiate it, you are going to get the same answer, but then this will make it more easy. So we have got this into 1 divided by root over 1 by v. If you take it inside the root, it will be 1 by v square, so it will be 1 by v square minus 1 by v square into v square by c square. So v square will get cancelled. It will be 1 by c square. Okay, just follow these steps. Okay, so you see now we have just one value. We don't need to use the product rule. एक में v है, so product rule नहीं चाहिए, right? So that becomes easy now. So now we can find out what is dk divided by dv, right? So I hope all of you remember your differentiation. dk divided by dv is equal to 2 pi m naught divided by h into ddv of 1 divided by, or maybe to keep things simpler, I can write it as 1 by v square minus 1 by c square whole thing to the power minus half. So this goes on top, so this will become minus half. Okay, so that's important. So we have this, and now what we are going to do is we are going to differentiate it, right? So ddv of this, that means we have to take the entire term and use nx to the power n minus 1. Let's try simplifying this, or maybe you can do it. So what I'll do now is I will leave it up to this point and ask you to solve it. Try solving, find ddv of the bracket and tell me what you are getting. The final result you can tell me, or maybe you can tell me the intermediate steps, and then we can proceed. So we differentiate it using the substitution method, but you know, when we derive such problems, 5 marks question, this question doesn't deserve that you have to, you know, show the differentiation also. But then I do understand that some of us might have forgotten things, so why not for just one time I will explain this, right? So what you usually do is we use substitution method. That means we can just, you know, write down this as 1 minus v square by 1 minus c square, and we can replace it with, let's say, variable x, right? So that means we have to find out ddv of x, right? So we can write it down as ddx of, you know, x into dx by dv, so that this dx and this dx will get cancelled and get ddv, right? So this is what we are supposed to do in substitution method. So this is not just x, because this is x, it is minus half, so that means I will put a minus half. Okay, I've just replaced this with x, minus half to rahega, so it is minus half. So you know, ddx of x to the power minus half and x to the power n minus 1, so this is minus half x to the power half minus half minus 1, so it is minus 3 by 2 into ddv of x. So what is my x? Is this 1 minus v square minus 1 by c square, right? Although I should not tell you this, but then this is something which you should do mentally. You don't need to do it in detail. I won't suggest that. So half x to the power minus 3 by 2. यहाँ पे भी substitution method you can use 1 by v square to be, you can do it, or even if you don't do it, it's fine, because you know this 1 by c square is a constant, so ddv of 1 by c square is 0. So I have to just do it for 1 by v square. V square matlab v to the power minus 2. So that means this will be minus 2 into v to the power minus 2 plus 1, minus 1, right? So minus 3. So that's it. So minus minus चला गया, 2 चला गया, x को we can replace. So x is 1 by v square minus 1 by c square minus 3 by 2 into v to the power minus 3. So you have to, you know, do it mentally. तो ये नहीं करना है, बिना करे you have to do it here, write it directly. Otherwise it's going to take a lot of time, right? Obviously we do understand that. This is minus of 3 by 2 into v to the power minus 3. We have a v here, we have a v here. Can we just do the adjustments? We can. Let's do it. 2 pi m naught h, this is there, and within this I can take this 1 by v square outside now. Let me take this 1 by v square outside now. If I take it, the power will also come, so it is minus of 3 by 2 into 1 by v square को बाहर ले लिया तो अंदर बचा मेरा 1 minus v square by c square, right? So that if I take it in, it will get the same result. This is minus of 3 by 2 into v to the power minus of 3, right? So if we do that, we can actually get our answer. So we have v to the power minus 3 is equal to, अभी ये देख लो, ये वाला adjustments is easy. 2 pi m naught divided by h into v to the power minus 2, it will go on top, okay, and then you can 2 gets cancelled and this will become v cubed, right? So if we just simplify this and do the sum, it will be v cubed, right? ऊपर चला जाएगा, right? So v हो जाएगा minus 2 into minus of 3 by 2, minus minus निकल गया, 2 cancel हो गया, v cubed, so it is v cubed into 1 minus v square by c square to the power minus 3 by 2 into v to the power minus 3 plus 3 minus 3 gets cancelled. So we have it as 2 pi m naught divided by h into 1 minus v square by c square to the power minus 3 by 2. Mark it as number 3. Right? Mark it as number 3. So what is 2? 2 is d omega by dv. What is 3? dk by dv. dk by dv. So if you have written, you already know what is d omega by dv. So we can just check for 1. Just check for 1. So if you go up, this is our first relation. This was the relation for group velocity. We can put and check and we can actually cancel out. See? So therefore 1 implies group velocity is equal to d omega by dv divided by dk by dv, right? From 2 and 3 you see what is d omega by dv. So d omega by dv, if you check from expression 2, it will be 2 pi m naught divided by h into 1 minus v square divided by c square minus 3 by 2 into v. That's the result for d omega by dv. And dk by dv, it's at the top. You can check, this is almost similar except the v divided by h into 1 minus v square by c square minus 3 by 2. Cancel, right? So we are left out with only v. Okay, so that's the proof. So maybe 5 marks, up to 5 marks for this. You have to write down all the steps. Sometimes you have to use some sentences. I have not used much, but I think you are smart enough to use some sentences there. Therefore vg is equal to v. This v that we are talking about is not the phase velocity, it is the velocity of the particle. So if you understand this, this is very simple. You are moving around, you are running, the velocity that you have, okay, but this is only valid for a relativistic case, so this is very important. Okay, the velocity that a particle has which is moving with the speed of c or compared to the speed of c is equal to the velocity of the group waves. Okay, so that means I have to conclude this is very important. only valid for relativistic particle. And I have already explained the maths behind this. Okay, very important. 5 marks for this. So this is only valid for a relativistic particle. So whatever we have done here, if you have followed the last 2-3 lectures on quantum mechanics, all these relations we have come across. We have just adjusted it, we have differentiated it, and we have got to this equation. The next topic that we are going to take is Heisenberg's uncertainty principle. But then since we don't have much time today, so what I'm going to explain today is the concept of wave packet. Okay, I'm going to explain you the concept of wave packet, which is actually important. And if we're clear about wave packet, we can check for Heisenberg uncertainty principle. Okay. So a question would be, it's an objective question, maybe a 2-mark or a 1-mark question. The question would be, what is wave packet? Okay, so we have to understand what is wave packet, and then only we can proceed to Heisenberg's uncertainty principle. 1 to 2 marks. Okay. So before I go to what is wave packet, I would like to just show you these 2 images, and whatever we have understood in the last few classes is actually shown here. So imagine you have got 2 waves, okay, and maybe they are out of phase, the wavelength is different. See, both these wavelengths are different. This frequency is higher, this frequency is lower, so the wavelength is very different. Okay, the amplitude may or may not be the same. If they combine, you are going to get a signal something like this. Okay, this third one, this is the signal that you are going to get. You can again separate them out using a tool like Fourier transform and all. You're going to get back these 2 waves again. Okay, so if you're talking about superposition of 2 waves, this is something which you are going to get. Okay, so in a way, this is actually called a wave packet. This is actually a wave packet which has got a number of waves combined. Okay, or on the other hand, if you have to have a number of waves whose wavelength, frequency are very close to each other, not much of a difference, and the amplitudes are the same, you are going to get this. This is the idea of group velocity, right? This is the idea of group velocity. So this is what you are going to get. So you will be having the constructive interference within this region, and remaining places it will be destructive interference. So imagine you have got an electron, okay, and there are these electrons will actually have that wave associated with them. Okay, so these waves, if I want to say that where the electron possibility of electron being there, that particular electron, because all the waves associated with it will be coherent, this will be within this region. Okay, so we can approximate the region of the electron. If you recall Thomson's model or Bohr model, where we say that the electron will revolve around the nucleus, that is something which is not actually correct, because today the latest atomic model that is valid is the quantum model. Okay, so based on this quantum model, we say that the electron will revolve around the nucleus and it will form a cloud. So it is a within that region. So we cannot say the electron will be here or here. We can say it will be within this region. Okay, so if you have understood this, this is actually the basic concept behind wave packet. Okay, so if someone asks you the definition of wave packet and you have to clearly explain this, we have to write down few sentences, and this is what I'm going to write down. Okay, so it's a 2 marks question, and I think this is also very important from your examination point of view. Okay, wave packet समझ में आएगा तब जाके next topic समझ में आएगा, which is Heisenberg's uncertainty principle. If you understand wave packet, you will understand Heisenberg's uncertainty principle. So the definition is, if more waves are considered, okay, we get a wave packet. Okay, it's not the definition, it's the basic understanding here. Let's just go for our definition, and I think definition is a bit long. Okay, I'll explain it to you line by line. So we have a wave packet, okay, and we can actually analyze. Okay, so a wave packet can be analyzed, okay, into, okay, or we actually can be synthesized. Okay, so we can actually synthesize means we are going to design a wave packet, synthesize, okay, or we can actually get it synthesized from an infinite. So we have got a large number of waves which will come together, okay, set of component, okay, sinusoidal waves. So although I'm writing down this definition, it's not that you have to write down the exact definition. You can break it up into sentences, write it down in your own words, you'll get your full marks, no problem. So a wave packet can be analyzed or can be synthesized from an infinite set of component sinusoidal waves. Okay, so you have a cos wave or a sine wave, both of them you can actually have it in the sine form. Sinusoidal waves of, okay, different wave numbers. All of them might have different wave numbers. That means wavelength might be different, slightly different, more different. It is a different thing altogether. Uh, with phases and amplitudes, okay, such that they interfere constructively. This is a very important term. Interference should be constructive. Constructive means constant phase difference or zero phase difference between all of these waves, okay, with phases and amplitudes such that they interfere constructively only over a small distance, a small region of space. So the second image that you see is basically what is defining it, okay, over a small region of space and destructively elsewhere. Okay, so the definition is this, but definitely you don't need to remember the exact sentence. You can write down the way you want to. Okay, the idea here is that we can have so many waves coming in, and all of these waves may have different wavelength, okay, phases, okay, or amplitudes, but then when they combine they are going to have a constructive pattern, and that constructive pattern is going to be within a very small region. Okay, then only that is actually called a wave packet. That means if you're saying there is a wave packet, and if you're saying that it is having this constructive interference pattern, it means that we can define that wave clearly and precisely. That's very important. Okay, इसी की वजह से we are using the term constructive interference. Outside this it is destructive. So if we have an electron and the waves associated with it interfere constructively, because we know that the electrons will show wave property. If the electron starts moving, as per de Broglie's wavelength hypothesis idea, we already know that it will have a wave associated with it. So it will move, it will have a wave associated with it, it will form some pattern. That pattern should be here within this region. Okay, that means we can say that the electron is within this region. Okay, so this is very important. In the next class we are going to discuss Heisenberg's uncertainty principle. That is actually not a derivation, that is actually just a hypothesis. So we're just going to define that uncertainty principle in terms of these images. Okay, we're going to see that, and then we are going to prove using Heisenberg's uncertainty principle that why electrons cannot exist inside the nucleus, right?